Moving further into our statistics chapter, we're going to talk about measures of center. In 12.3, we discuss the 4 main measures of center: mean, median, mode, and mid-range. Now this this section is going to be a little difficult without our manipulatives and our groups to work in, but we're going to figure it out. Okay, our symbol for mean is X bar, and the mean is what you refer to when you typically talk about average. It's the arithmetic mean, or average. So when you talk about your test average, you're talking about the mean. To find the mean, X bar, again, stands for mean. You take the sum of the values divided by the number of values. So, for example, this would be my test scores. This little pointy E is a Greek sigma. It's a sigma. And in math, it means sum, or that I'm going to add things together. So I add together my data points. In my example, this is going to be my test grades, and I divide it by the number of data points. For example, if I take 5 tests and I don't want to know the mean or the average of my test grades, I add those 5 tests together and divide by 5. Median is another measure of center. It is literally the center point, or the value in the middle. When I say the value in the middle, I'm assuming that I have ordered my data from least to greatest. So I have to have all my data points in order to find the median. When you're trying to remember which one median is, think about that word median. Where do you see a median in life? Well, it's that center of the road that divides the opposing lanes of traffic. That's the median. It's the middle, literally the center. All right, mode is another measure of center. Our mode is the value that is the most frequent, the one that shows up the most. It's possible to have no mode because you don't have any values repeated, or to have more than one mode. We could have a data set that is bimodal. Bimodal would mean 2 modes, or trimodal means 3 modes, because you have more than one value that's repeated the same number of times. Mid-range is our last measure of center that we're going to talk about. To find the mid-range, you take the lowest plus the highest values. So you find the sum of the lowest and highest value and you divide by 2. So basically, to find the mid-range, you're taking the average of the lowest and highest point. Okay, we're going to practice. We're going to find the mean, median, mode, and mid-range for each of these data sets, A through E. Now, before we start doing the calculations, and you're going to need your calculator for this part, before we start doing the calculations, I want you to look and see how many data points you have for each list. For example, for list A, 1, 2, 3, 4, 5, N is 5. We have 5 data points. Now we're going to start by finding the mean. And I want you to find the mean of all of the data sets, all 5 data sets. Start by finding the mean. To find the mean, X bar, you're going to add up all the data points and then divide by the number. So in this case, I'm going to add 91 plus 95 plus 99 plus 97 plus 95. I get a sum of 477, and I divide that by 5 because I have 5 test grades or data points, whatever they are. And I get a mean for this data set of 95.4. I want you to pause the video, find the means of the other 4 data sets. Okay. If you didn't get one of these right, go ahead and stop and check your work and see if you can figure out what went wrong before we move on. The next thing we're going to do is find the median. To find the median, remember, we have to know the middle. So we have to have our data points arranged in order from least to greatest. They're not in order from least to greatest. So the very first thing I have to do is I have to go in and I have to rearrange my data set. Now, when I rearrange this first data set, I see that this 95 is the median because it is the middle score. You're going to notice that in these first two, at least, my mean and my median are not the same value. That's fine. There's no way the mean for set A was going to be the same as the median because the mean in set A is not one of my scores. The mean in set B is not one of my scores either, so it couldn't have been the median. Okay, so for the first three data sets, we're rolling right along. We're doing good. We've got 5 data sets. We pick the third one because it's the center. 5 data points, pick the third one because it's the center. 9 data points, we pick the fifth one because it's the center. There's 4 below, 4 above. When I get down here to D, though, I have 6 data points, an even number, not an odd. There isn't a center. If I look right here, the center is going to be between those 2 data points. My median does not have to always be a value in my list. If I have an even number of data points, I'm going to take the middle 2 and find the average. So to find the average of these middle 2, I add them together and divide by 2, and I get a median of 95. In E, I have an even number of data points again, so I'm going to have to look at doing the same thing. So I find the middle 2, and I average those 2 together to find the center of the middle 2 values, and that center of the middle 2 values is my median. All right, let's go back and look at mode. Mode is the value that shows up the most. It's the most frequently represented value. In my first list, my mode is 95 because it's repeated twice. No other values are repeated. My second list does not have any repeated values, so there is no mode. My third list has a mode of 0. Notice that these two answers are not the same. 0 is a value that can be the mode. If there is no mode, I have to say none or no mode. If I said 0, I would be naming a value as the mode. So make sure you answer that correctly. When I get down to E, E is bimodal. 75 and 82 are both listed 2 times, so they are both modes. It is bimodal, B-I-M-O-D-A-L. All right, and then our final column is the mid-range. The mid-range, remember, is the average of the highest and lowest data points. Since we already have them in order from least to greatest, it's easy to locate the lowest and highest. So for set A, I'm going to take 99 plus 99 and divide it by 2. That gives me a mid-range of 95. So find the mid-range of the other 4 data sets. Okay, again, make note that my measures of center are not all the same. Set A, data set A, comes the closest because I have 3 values 95 and one is 95.4. Set B, mid-range and mean are the same. Set C, I've got values all over the place from 0 to 6. Set D, from 65 to 100, depending on how I look at it. Set E, the values are all pretty close. How do I decide which is the best measure of center to use? Well, it depends on why I'm asking. If I'm looking at set A and I say, all right, well, how did the class do? These are test grades. How did the class do? Well, they did very well. No matter how you look at it, I've got a good center. They're consistent values. If I look at set C, however, let's say these are quiz grades, and you say, how did the class do? Well, it's a very different picture depending on what you look at. If I look at mode, the class did not do well. More people made a 0 than anything else. But you might have to ask a follow-up question. Why did they get a 0? Did they get a 0 because they weren't there? Did they get a 0 because they didn't prepare? Why did they get a 0? If I look at mean of 4, well, that may not be fair either, because when I have these 3 zeros, that's going to pull that average down significantly. If I eliminated those 3 zeros and I just looked at the scores that were earned, well, the center of those would be about a 4 or 5 if I'm looking at median. So those outliers, those low values, pull down my center, and you need to decide whether or not those should be included. Set D, again, we've got this outlier of 30. That's significantly lower than the rest of the scores. If I eliminated it, my mean would be much better. Almost everyone else had an A. We had a C, we had a 70, and then we had that 30. So it changes the mid-range, for sure it brought it down, and it also brought the mean down. So maybe the median would be a better measure of center for that data set. Let's look at the next page. Now the next page, we move into an investigation that involves using tiles. My tiles are just little squares that we were going to work with. I didn't bring my tiles home, so I don't have them to arrange and rearrange for you. I don't have tiles, but I do have a whiteboard. So instead of stacking tiles, we're going to try to do this by drawing pictures on my whiteboard. It says create the following stacks: 3 tiles and 7 tiles. So we're going to do that, and you can do this on your paper. You can draw this on your paper. When I say stack, we're just going to line them up like I were laying them in rows, in columns. Let's make columns rather. So we've got 3 tiles and we have 7 tiles. 1, 2, 3, 4, 5, 6, 7. So we have a column of 3 and we have a column of 7. Now rearrange the tiles so that you have 2 stacks that are the same height. All right, well, I have a short stack and a long stack. So what if I take some of these and I move them over? So let's take maybe these 2 and move them over here. So I took them from the long stack and I moved them to the shorter stack. Well, now they're equal. Did I do away with any tiles? Well, how many did I start with? 3 plus 7 is 10. I still have 1, 2, 3, 4, 5, 6, 7, 8. I still have 10 tiles. So I kept the same number of tiles, but now they're in 2 even stacks, and each stack is 5 tiles tall. So each stack is 5 tall. Let's do the next one. This says to create stacks of 2 and 10. I'm going to do circles this time just because it's quicker to draw circles. So I've got 2, and then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got a total of 12 tiles. I've got a stack of 2 and a stack of 10. There we go. Rearrange them so that I have 2 stacks that are the same height. Well, I've got 12 tiles total. I'm going to start moving tiles over. So 1, 2, 3. Let's start with 3. 1, 2, 3. Still not even. I need to move 1 more. Do I still have 12 tiles? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I do. I still have my 12 tiles. They're in 2 even stacks, and I have 2 stacks of 6. Let's look at the next one. Create the following stacks: 5 tiles and 9 tiles. So how many total do I have this time? Well, I'm going to have 14 total. I've got 5, and I'm going to go across this time so it's easier to see. There's 5, and then 5, 6, 7, 8, 9. I've got a row of 5 and a row of 9. I need to rearrange them so I have 2 that are the same. Well, how many am I going to need to move? This row is 4 longer than that row, so I'm going to need to move half of those. I'm going to move 2 of them. And now I have 2 equal stacks, and each stack has 1, 2, 3, 4, 5, 6, 7. 7 tiles in each stack. Notice that we are focusing on the sum of the tiles. Notice that we are focusing on the sum of the tiles. All right, we've got 3 stacks this time. We've got 2, we have 9, and we have 4. Remember, you can pause me to work and then start it again. Rearrange the tiles so you have 3 stacks the same height. Well, this one definitely, let's take 2 off of it and put them here. Oh, we're close now. We've got 3 extras. We've got, let's put 1 here and 1 there. And now we have 3 equal stacks. 1, 2, 3, 4, 5 times 3. Each stack is 5 tall with a total of 15 tiles. 2 plus 9 is 11 plus 4 is 15 tiles arranged in 3 stacks. Each stack is 5. Are you starting to get the picture of how we're doing this? Now I know how you know how to do this arithmetically. I want you to be doing it physically so that you're focusing on the sum, on the total, and on the rearranging. So 4 stacks this time. We've got 2, 4, 8, and 6. 2, 4, 8, and 6. Well, how many total is that? 6 and 6 is 12, and 8 is 20. I have 20 tiles in 4 stacks, so I have in my mind about how many I think I'm going to need. I'm going to take these 2 and I'm going to put them there. I've got 4, 4, 1, 2, 3, 4, 5, 6, and 6. Let's take 1 each off of these 6 and add it, and we've got 4 stacks of 5. So each stack is 5 tall. What measure of center are we doing? Well, we're taking the sum and then we are dividing them into a certain number of stacks, so we're dividing them easily. That measure of center that we are constructing is the mean, because we are rearranging or leveling off, I can't spell today, leveling off to create the average stack. We're rearranging or leveling off to create the average stack. Okay, let's look at the next page of notes. Now we've got a challenge. So I want you to do what we're doing, play with circles or squares, or if you have something to actually rearrange, then do it, and see if you can come up with a data set. Now, we're working backwards. You're going to use tiles to help you create a data set of 4 values with a mean or an average of 5. So no numbers can repeat. That's my rule. I can only use each number 1 time, and I'm going to play with numbers until I get something that has an average of 5. Well, if I have 4 different numbers I need to list with an average of 5, I'm working backwards here. I've got a total, I divide it into 4 stacks and I get an average of 5. What's my total number of tiles? Well, if I'm dividing to get 5, if I work backwards, what's the opposite of division? It's multiplication. If I have 4 stacks of 5, how many total tiles is that? Well, that's going to be 20, because 5 times 4 is 20. 20 divided by 4 is 5. So I am taking 20 tiles total, and I'm arranging them into 4 different values. I don't want any values to repeat. I need 4 different values. Now, if we were in the room together, no, everyone would not be choosing the same values. I want you to pick 4 values that will add up to 20, and you can not use any number more than 1 time. Do yours, and then I'll do mine. I'm going to use 4, 6, 3, and 7. But you might have used 1, 2, 3, and 5, 6. That would be 14. Or you could have done 0, 5, 10, and oh, I can't use 5 again, so that wouldn't work. How about 0, 4, 10, and 6? Those add up to 20. So there's 3 different data sets that have a mean of 5. 4 values, 4 values, 4 values. They all have a mean or an average of 5. All right, do it again. This time, Your challenge is to create a set of 5 values with a mean of 6. And you have to use at least 2 different numbers. You can repeat things this time, but you have to use at least 2 different numbers. Again, not everyone's going to use the same values, but what should everyone's values add up to be? If we have 5 different values, 5 different slots to fill in, and that mean the average of those 5 is going to be 6, well, 6 times 5 means I need to start with 30 total tiles that I'm divvying up into 5 piles. I could use 5, 5, 5, 5, 10, 15. That means I would have 15 more left. I could do 5 and 10. That's 2 different numbers, and those add up to 30. I could use 10, 10, and then 5, 2, and 3, because that's 25, 30. These are data sets, 5 values that have mean of 6. If I add them up and divide by 5, the average is 6. All right, let's look at the next one. The mean score for 5 tests is 80. The mean score for 5 tests is 80. Work with your group to find 3 different possibilities for the 5 scores. Well, you don't have a group, but we know that we added up our 5 scores, we divided it by the number of scores by 5 test grades, and we got a mean of 80. So how many points total was earned? Well, 400 points were earned because 80 times 5 is 400. So we are dealing with 400 total points that we are dividing into 5 test grades. 1, 2, 3, 4, 5 test grades. So that if I have 400 points divided by 5, I'm going to have a mean of 80. We're supposed to find 3 different data sets. So there's 5, there's one data set, there's a second data set, there's a third data set. Okay, I don't have any restrictions on the actual grades. So you know what? All 5 grades could have been 80. If I make 5 80s, my average is definitely 80. I could have made a 0. I could have made 100, 100, 100, 100. That gives me 400 points. So that works. Or maybe I made a 60 and an 80 and 100 and a 90. How many points do I have here? I have, add all those up in your calculator. You've got 190, 270, 330. That one would need to be a 70 to have a mean of 80 because that's a total of 400 points. Okay, so let's answer these questions. You may have given 5 different test grades. That's absolutely fine. That's just 3 different possibilities that I came up with for the 5 test grades. Can all 5 grades be the same? Yes, they can. They could all be 80 and have an average of 80. So yes. Now, could all 5 scores be less than 80 and have an average of 80? Well, no. If they're all less than 80, your average is not 80. Could all 5 scores be more than 80 and have an average of 80? Well, no again. If your grades are all higher than that, that is not going to be your average. All right, let's look at the next page. The mean score for 5 tests was 75. What is the total points earned, the sum? Well, I've got a total divided by 5 because I have 5 test grades, and the mean was 75. What is that total? Remember, the opposite or the inverse operation of division is multiplication. So the total, to find the total, I would do 5 times 75. So that's a total number of points, 375 points earned. What if a 6th test is taken with a score of 90? What's the new mean? Well, we just said if on the 5 tests we earn 375 points. We add 90 points when we take the 6th test, and since that's the 6th test, we're dividing that by 6. So that would give us 465 divided by 6, which is a mean of 77.5. Did we expect that grade to bring our mean, our average up? Well, yes, because it was better than our average, so it's going to bring our average up. What if we had made a score that was 60 on that 6th test? Would it have brought our average up? Well, no, it would have brought it down because it's lower than our average. All right, number 5. A class of 10 students has a mean of 76 on a quiz. There are 6 girls, and they had a mean of 77. What was the mean of the boys' quiz scores? Well, let's start with our class total. 10 students had a mean of 76. So how many points did the students earn? Well, 10 students with a mean of 76 means that they earned 760 total points. Now we have information about the girls. We know that there were 6 girls and they had a mean, an average of 77. So those 6 girls with an average of 77 earned 462 of those 760 points. So if the girls earned 462 points, that means the boys earned 298 points because that's the difference. Well, how many boys were there? If there were 6 girls out of 10 students, that means the other 4 were boys. So those 298 points were earned among those 4 boys, which means the boys had an average of 74.5.